Hello, how are you everyone? I am fine, thanks to God. Now today I will present you the second chapter of C++ programming, C++ Basics Part 2, Basic Data Types in C++ Programming. Okay, please like, share, subscribe before start this video. And as introduction, as we see in the first part, types of variables, then how we declare a variable and identifiers also we will see. Now today we see about the basic data types in C++ programming. When you define a variable in C++ programming, you must tell the compilers what kind of variable is it. What kind of variable is it? This information tells the compiler how much room to set aside and what kind of value is held by this variable. This is the point. This is the point. Good. Several data types are built into C++ programming. The variety of data types allow programmers to select the types or appropriate to needs of the application being developed. So this based on this need, data types supported by C++ can be classified as these three fundamental categories or groups. The first one is fundamental data type. The second one is user-defined data types, and the third one is derived data types. C++ supports these three types of data types. Good. Basic data types can be subdivided into again numeric value and character value data types. As the name indicates, numeric, it accepts and holds only number in the number type, and characters also holds character and it is family string is a collection of characters like that. Numeric variables can further subdivided into integer values and floating point variables. For an integer, for example, int a is equals to 3. This is integer variable. Int b is equals to 2.5. This is floating variable. And from this, the first one, that means numeric variables, this one, floating and integer, expressed in integer number and in floating number or decimal numbers. And the character is char, for example, char f or char m, like this. Both the numeric data types offer modifiers that are used to vary the nature of data to be stored. For example, short, long, signed, unsigned. As you see from this table with their size, unsigned short int 2 byte of memory size with a value of 0 up to 65,535 values. It can hold up to this. And these all are C++ data types with their range and size. This up to this, and this is the size, and this is the value or the range of this data type. So you can see it one by one on reference. Thank you. Then the next one is characters. What is characters? As the number, as you see from the previous slide, number data types are integer part and floating point part, and also the second variable type is character variables. Character variables type char is declared by char symbol are typically 1 byte size, enough to hold 255 values, data values. And a char can be interpreted as a small number 0 up to 255 or as a number of the ASCII set, American Standard for Computer Information Exchange symbol. it stands for. So ASCII code, the American Standard Code for Information Interchange, the ASCII character set, and it is ISO, International Standard Organization equivalent, are a way to encode all the letters and numerals, and including punctuation marks, numeral symbols, and letters on your keyboard. You know, this ASCII character or standardization. In the ASCII code, the lowercase letter a is assigned to the value 97, and all the lower and upper letters are its own numeric value. And all the punctuation marks are also assigned values between 1 up to 128. Another 128 markers and symbols are reserved for use by the computer markers. Also, the IBM extended character has become something standard. Characters and numbers. As you know, when you put a character, for example, a into a character variable, what is really there is just a number between 0 and 255. What value? So the compiler knows how to translate back and forth between the characters and one of the ASCII values. So there is a big difference between the value 5 and the character 5. When you put this char, when you declare characters, you should put under quotation mark 5 and int 5. This is different value. The letter is actually used at 53, and the character also have its own value. So this is all about characters, and the next one is the second one is constants. C++ introduces the concept of named constant that is just like a variable, except that it have its own unchanged value or cannot be changed once you declare its constant value. The quantifier const character keyword tells the compiler that it is built-in keyword actually, that a name represents a constant. Any data type, built-in or user-defined, may be defined as const. You can declare based on your interest or users need as a const one variable value, and you can use it throughout the program or the source code. If you define something as a constant, then attempt to modify it, the compiler will generate an error because you can already declare once or give a value, unchanged value. For example, for const float pi is equal to 3.1416. This is a constant. Once you declare it, you use it as it is. You cannot change it. Const double sales tax is equal to, this is user defined built-in, because pi is already known by every mathematicians. Const double sales tax is equal to 0.05. This is user defined constant variable. User defined. So this is built-in, already built-in variable. Const int max num is equal to 100. This is also user defined. So constants, when you assign a value for a constant, you cannot change it throughout the program, rather use as it is. Once declared, the constant can be used in any C++ system in place of number it represents. Good. Input output statements. What does mean? For example, you want to input some data value to your variable, or you want to display the console one variable's value to the user. The most common way in which a program communicates with the outside world is through input and output. Character-oriented input-output operation. C++ provides two useful operators for input and output. This and this one for input and output purpose. The cout object is an output object. Cout object is an output object that sends data given to it to the standard output display device, any device that the system displays for the user. To send a message to the cout object, you use the following pattern, like cout, this character symbol, under a quotation, write any text that you want to display on the console or display object, then quotation under quotation mark the text should be and terminated with a semicolon, like this. For example, cout date operator and quotation hello world, then terminate with the semicolon, like this one. The cin object is an input object that accepts data from the standard input device. To accept a message from the cin object, use the following pattern, like this: cin, this input operator, the text or variable that you want to accept from the user to the system, then terminated with a semicolon termination symbol. Good. Then the next one is the sample source code, how it works. Started from this one, including the header file using this hash include astem.h. This header file is used for standard delivery for input output operation. And int main, it implies this int is a return data type. It returns in an integer data type. And this one is a main function. C++ have its own main functions. From this main functions, main function is one of the main functions that in C++ we use. And this is a function declaration. And this is open brace, opening of the function. Int workdays is equal to 5. Int is an integer data, and workdays is a variable having a value 5. And float workhorse equals 7.5, and also float is a data type, and workhorse is a variable having a value of this float variable value. Float pi rate weekly pi, float data type, and this is two variables. Then see out what is the hourly pi rate, cin, accept the input data. Weekly pi is equal to this operation takes place, this times this times this, and see out weekly die, because this we have two constant values, and we multiply it by given pi rate variable value, this one, and see out weekly pi is equals to weekly pi, the result of this operation, weekly pi, then see out slash new line and close the main function. This is sample fragment code to accept the weekly dice work hours and calculate with their pi rate and weekly pi out value or result. Good. What's operator? What is operator? Operators in C++, how it works? Operators, okay, C++ provides operators for composing expressions. These are arithmetic operators, relational operators, logical operators, bitwise operators. Arithmetic operator, as we know, it contains plus, minus, multiplication, and division. Sometimes modulus. Relational operator, logical operator, bitwise operator have its own application area with its own meaning. It also provides operators, operators which produce useful side effects. Assignment, increment, decrement, we will see in the future or in coming sessions. C++ provides for an arithmetic operation, this, as you see, this one. For example, this gives us this gives us this. It is a common and ordinary information for you, except for remainder or modulus operator or other arithmetic operators can accept a mix of integers and real operands. Generally, if both operands are integers, then the result will be also an integer. However, if one or both of the operands are real, then the result will be a real or double to be exact. The remainder operator modulus expects integers for both of its operands. Yeah, ቀሪውን ስለሆነ የሚያስቀምጥልን ማለት ነው. It only displays the remainder of the operands. It returns the remainder integer dividing the operands. Okay, good. Arithmetic operator integer division always results in integer outcome. That means the result is always rounded by down. For example, 9 over 2, the output is 4, not 4.54. It is illegal to divide number by 0. We will know. It is a fact. We know as it is. Take as it is. Assignment operators are, as we know, to assign a value for one variable. Assignment operator is used for storing a value at same memory location, typically denoted by a variable. Let us left operands should be an L value, left value, and its right operand may be an arbitrary expression. The latter is evaluated and the outcome is stored in the location denoted by that value, L value. The left value is anything that denotes a memory location in which a value may be stored. For example, A is equals to what? 10. A is equals to 10. From this assignment operator is used to assign this value to this variable. I think this understand. Sorry. It is clear, I think. Okay, the next one, the assignment operator has a number of varieties ability obtained by combining it with the arithmetic operator. Syntax: variable identifier is equals to expression, like this one. Description: the expression is evaluated and the result value is stored in the memory space reserved for that variable identifiers. You see this one? Good. So the next one is the assignment operator. As you see, is assign variable operator n is equals to 25, for example. Increment operator n is equals to n plus 25. N is equals to n plus 25. Decrement operator n is equals to n minus 25. Multiplication also as a multiply operator is equals to n times 25. Division operator also n is equals to n over 25. And also the modulus operator n is equals to n module 25, like the same for others. So general assignment operator is used to assign the on left value to variable on the right value. Assign values on left to the right. Values are this from the right, and assign this value to the left. So left to right, left to right. Binary operators to operands can say to operands this and this. Example: int a is equals to 5, left to right. Float b is equals to this value, the same as true, and also ch is equals to character value d under quotation. This is assigning a value to the character. Good. Relational operator, as the name indicates, it makes a relation. For example, this is an equality operator, this is inequality operator, not operator, and less than or equal to, greater than equal to. This is a relational operator. We will see in practical session using a fragment of codes. Good. And then the next one is relational part. The operands of the relational operator must evaluate to a number. Characters are valid operands since they are represented by numeric values. Just for capital A and small a have its own value, so we can compare the numeric value. Gives one is like 65 less than 70. 65 for A less than 75 for F, capital F. Yes. Good. The relational operator should not be used for comparing strings, not comparing strings. It is used for comparing integers or numeric operands, because this will result the string address being compared, not the string component. The string address memory under the memory location, the string address, not the string as it is. So relational operator is used to compare the operand values. C++ provides library functions. Example, string compare, built-in library, built-in library, just built-in library, built-in library for the lexicographic comparison of strings. Alphabetical ordering, order, alphabetically, alphabetically ordering characters or strings alphabetically. String compare built-in function. Okay, good. C++ provides three logical operators for combining logical expressions. Operator, for example, not operator, and operator and, or operator, logical operator. For example, not 5 is equal to 5. Not 5 equal to 5 gives 0 because it is not operator. 5 less than 6 and 6 less than 6 gives 1. It is true. 5 less than 6 true, and 6 less than 6 is false. What you see? What's behind here? 5 less than 6 or 6 less than 5 true. It is false, this, or operator. Logical operator true, 6 less than 6 false. What will be the output? 5 equal to 5 not, meaning false or no. So logical negation is unary operator which negates the logical value of its single operand. If it is operand is non-zero, it produces 0, and if it is 0, it produces 1. Yeah, negation. No? It is a negation operator operand. Good. Logical end produces 0 if one or both of its operand equals to 0. Otherwise, it produces 1. If one of the two produces 1, produces 0 if one or both. It produces operands equal to 0. For example, 5 equal to 4 and 5 greater than 4. For example, the first operand is 5 equal to 4, false, yes, false, and 5 greater than 4, true, false and true, or the output 0 and 1 is output 0. So the logical end operator is 1 when both of the two operands value generates 1 or 2. Otherwise, its result is 0 or false. Logical OR provides 0 if both of its operand equal to 0, unless one of the two may, if I have one value, it produces positive value, or 1 produces. Valid logical expressions are not 20 gives 0, 10 and 5 gives 1, 10 and 5.5 gives 1, 10 and 0 gives 0, one of the two 0. C++ does not have a built-in boolean type. It is customary to use type int for this purpose instead. For example, int sorted is equal to 0, meaning sorted 0 meaning do not sort the value of the array list. For example, there is a list of records, so int sorted is equal to 0 means does not, please do not sort this value, array value. Int balanced is equal to 1 meaning take balanced, or please be balanced, the given value. Good. Then the next one, bitwise operators. Operator description example. bitwise or, bitwise and, bitwise complement, bitwise XOR, left shift, right shift. This is also bitwise operators. For example, compare corresponding bits of two operands. If either of the bits is 1, it gives 1. If not, it gives 0. A or B. 29 is equal to 29. One of the two, if one of the two have its own value, it can, unless it is value, it gives 0. If both bits are 1, it gives 1 bitwise end. Otherwise, it gives 0. A and B is equal to 8, meaning both A and B have its own 1 value. Bitwise complement inverts the bit pattern. It makes every 1 to 0, every 0 to 1, and every 1 to 0, vice versa. Convert. Complement A. Bitwise complement A is equal to 1, 1, 1, 1, 0, 0, 1, 1. Meaning A is equals to 0, 0, 0, 0, then 1, 1, then again to 0. This is the output. Negation bitwise XOR. If corresponding bits are different, it gives 1. If corresponding bits are same, it gives 0. Like that, A XOR, negation of A XOR B is equals to 10 to 1. It compares each corresponding value. Okay? It compares its corresponding bit value, and it gives 1 if corresponding bits are the same, unless it gives 0. For example, 1, 1, 1, 1, and 1 for a comparison. 1, 0. So the output is this and this. 1 and 0 XOR 0 negation ስለሚሆን if corresponding bits are same, it gives 0. If bits are different, if corresponding bits are different, it gives 1, meaning opposite. 1, 0, 1. 1, 1, 0, 0, 0, the remaining. Like this one. And left shift and right shift is the same as like that of this XY plane. And shift to the left and to the right. To the left and to the right n times based on the values that you have given for shifting. Yes, right. Also for right, left, and shift, shift. Then the next one is a bitwise operator. Bitwise operators accept or expect their operands to be integer quantities and treat them as bit sequence. Bitwise negation is a unary operator which reverses the bits in its operands. Bitwise and bitwise negative. Bitwise negation, bitwise and. Compares the corresponding bits of its operands and produce a 1 when both bits are 1 and 0 otherwise. Just like as shown in the previous slide, like this one. If both 1 and 1 produces 1, 1 and 1 produces 1, 1 and 1 produces 1, 1 and 0 produces 0. The reverse of XOR, bitwise XOR. That is true for bitwise and. Bitwise negation in our present that I told you. Bitwise or compares the corresponding bits of its operand and produces a 0 when both bits are 0 and otherwise. If 2 of the operands are 0, it produces 0. Otherwise, one of the two may be 1 and it gives the result 1. Bitwise exclusive or bitwise left shift operator is the same for that. Okay, increment and decrement operators. Plus plus var, var plus plus, minus minus var, var minus minus operator. The name pre-increment, post-increment, pre-decrement, post-decrement. So, this, as a description here, increment var by 1 and use the new var value in the statement. Int j is equals to I plus plus I. J is 2. I is 2. Assume the first value is I is equals to 1. Here j is 2 because plus plus I. First increment and give the value for j, the value of I, and I value is incremented. And j is equals to I plus plus. J is 1, the value of the I first value, and after I is incremented. J is equals to minus minus I. Please decrement the value of I and assign the value to the j. So the value of j is 1. When we decrement it 0, then the value of j is 0 and I also 0. I minus minus, first assign value of I to the j and decrement the I value. This is the increment and decrement operator. Good. Then the next one is the increment decrement operator. Here are additional examples to illustrate the difference between the prefix form of plus plus or minus minus and the postfix form of plus plus or minus minus. Consider the following code: int I is equals to 10, int num new name is equals to 10 times I plus plus, cout I is I, num is num. Same effect is I int num is equals to 10 times I is equals to I plus 1. Yes, it is post increment. And this is the pre-increment. First increment the value and assign that value or update that value. This is post increment and pre-increment the value, and this is post increment, this is pre-increment actually. After incrementing the value, assign it. This is assign the value and increment that value again. Okay, good. From here, I 10 plus I 10 plus 10 20. I is 11 and the I times I is 100. 10 times I 10 times 10 100. From this I 10 names got 10 times increment first. As you see this bracket, increment first I is 10 plus 1 plus I means plus 1, 10 plus 1 11. So 10 times 11, then the output is 110. The age value is 11. I think this is clear. And also you can see this one. What does it mean? I plus plus means, or plus plus I mean. Good. Then the next one is increment decrement operator. And x is x, a, b, c. A is equals to 2, b is equals to 4, c is equals to 5. X is equals to a minus minus, meaning a minus minus means a is 2 plus b plus plus means b is 4 minus plus plus c 5 plus plus first update the value of c by one value 6, then the value is equals to 0. What the value of x is 0. What the value of a x is equals to this one, a is equals to 1, b is equals to 3, because it incremented by 1, b is equals to plus plus b plus plus 5, b plus plus 5, c is equals to plus plus 6, incremented by 1, decremented by 1. I think this is a solution of this problem. Yeah, x is equals to a minus minus plus x is 0. Yes, right. B plus plus a minus minus. First used the value of b into expression, then increment by 1, as I told you. The same. Good. Then precedence of operators is the next section. The order in which operators are evaluated in an expression is significant, and it is determined by precedence rules. These rules divide the C++ operators in the number of precedences level. Operators in higher level take precedence over operators in lower level, like this table. This table is rules that we give a precedence for each operator, right? You can see this each operator, which is a precedence. I think it is clear. What is it? Unary, binary, kind, order, both, right, left to right, right to left, and the same for each operand. It is some precedence. Higher precedence is the first. Higher precedence is given for first operation. Good. The precedence of operators, as you see in the first slide, in the previous slide, you see an example. For example, a plus b plus c plus d plus e. Which operator is first takes place? You can do left to right without precedence, giving precedence, because they have the same. For example, for this, which operator is given first? The first one is multiplication operator, then the second one the division operator, then the third is addition operator, and the fourth one and the last one is this division operator. Good. From here you should first calculate or compute this, the bracket operator, and then the next one is the division operator, and then the third one is the modulus operator before addition and subtraction, and the last one is the addition operator. Good. From here the first one is the inner bracket, this one, and the second one is the next outer bracket, this one, then the next one is this multiplication sign, and the last one is out of the big bracket, the division, this operator. Good. Example, what is the following expression? 3 plus 2 times 3. Which is the first one? The first one is this multiplication. 2 times 3, 6. 6 plus 3 is equals to 9. 3 plus 6. Good. Then the second one is 50. How it works? Because 3 plus 2, 5. 5 times 3 is equals to 50. 23 plus 4 times 5 over 2 modulus 3 minus 7 is equals to 17. How it works? Like that the previous one, you should first multiply this 20 over 2, 10. Then the second one is modulus 10 modulus 3 1 plus 23 plus 1, 24 minus 7, 23 plus 1 minus 7 is equals to 17. 24 minus 7 is equals to 17. This is the right. Yes. Good. Then the next one, simple type convergence. C++ allows us to convert data of one data type to that of another. This is known as type conversion. Here are two types of type conversions in C++. The first one is implicit conversion, and the second one is explicit conversion, also known as type casting from one data type to another data type when we want to cast. Implicit type conversion, this types of conversion is known as automatic conversion. For example, int num int is equals to 9, double num is equals to num double is equals to num int. This is cast changed to this one. For example, double 9.99 int num int is equals to num double, meaning this value is given to this integer value. Yes, this is implicit expression. Good. The second one is explicit conversion or casting. When the user manually changes the data from one data type to another, syntax type expression. For example, double x is equals 1.5. Int sum is equals int of x plus 1 means the result of this expression is changed or casted to integer value. Yes, because x is first in double value, 1.5, 1.2 plus, like this, 1.2 plus 1 is equals to 2.2. When we cast it int 2.2, meaning the output is 2, like this one, 3.14, sorry, 2.02. And when we double, casting to the double, the reverse is to 2.0 at the fraction part. Good. This is the exercise. Write a statement or comment to accomplish each of the following tasks. State that the program calculates the product of three integers, x, y, and z, and how it is on result to be a value, data type value of that variable is integer. Prompt the user to the enter three integers, accept from the user three integers, read three integers from the keyboard and store them. Before first open the code block to complete this exercise. I will show you one by one, and we try to solve this problem. And I have also give another problems to solve how the problem based on the lecture that I showed you, present you. Compute the products of the three integers containing x, y, and z, and assign the results to a result variable. The variable of the result is result, and with its data type int. Print the product is followed by the value of the variable result. Product is result. Return a value from main, indicating that the program terminates successfully, meaning return 0. Good. Yeah, this is a code block how to complete this problem. Right click on the create project and also click this console application. Next, C++, next, add this product of three integers. Okay, and then the compiler is GCC compiler finish. Alright, okay, this is already generated code. So from here you should declare variable, three integer variables, int x, y, z, and result. Good. So first accept these three integers from the keyboard. Size the quotient. State the program calculates three integers. Yes. Declare three variables. We already declare. Prompt the user to enter three numbers, meaning orders to accept the integer, this integer. So it implies cout, please enter three integer numbers. Please enter the first integer number. Then here cin x. Again this cout the second integer number. Yes, and then please enter the second integer number. Okay. Indel meaning new line. Again cin the second number x, y, and then cout again the third integer number. Please enter the third integer number. and then good C in this third number. What's the remaining variable? Z. Z. Then the product of these three numbers, result is equals to x times y times z, and display cout the question size. Finally, compute the product integer containing the variable x, y, z and assign the result to that variable result. The product, print the product is followed by the value of that result. Return a value of the indicated terminated successfully. Okay, come back to here, cout the result. The product is this result. This, when you compile this, first compile, I think no error, where's the error? Yeah, this additional double comma is not necessary. Compile again. Y was not declared in this scope. Where? Here, yeah, this is capital Y. I already declared small y, because in C++ variables are case sensitive. Good, no error is found. 0 second, 1 second, terminate the compilation. Run this project. Please enter the first integer 5. Please enter the second integer number 6. 5 times 6 times 10. Please enter the third number 10. The product is 300. 5 times 6, 30. 30 times 10, 300. Process terminated. Execution time with this pressing key to continue. Yes, this is the result based on the instruction that we have ordered from the question. Good. Then the next question is, write a program that accepts two integers and displays their sum, their difference, their product, and their division of the numbers to these two numbers. The program should also state the greater and smaller numbers from these two operands. First, accept two numbers. Okay. It is better to open another project, mpt file, two integers. There is operation. Okay. It is better to copy the whole code, or we can do as it is from here. Integer x and y. Then we should assign a variable for each: sum, comma, difference, comma, product, comma, prod, comma, remainder. Remained. Is it enough? Remained. Okay. Then please enter the first number in x and y, comma y. We have two integer numbers. In x, out the second number. In y, it is not necessary. Okay. Then result, instead of result, sum or product. Prod is equals to x times y, comma, sum is equals to x plus y, comma, difference is equals to x minus y, semicolon. Then the final is remainder or remainder is equals to x over y. then cout for each, cout like this. The product is prod handle. Okay, then copy this as it is and paste. Okay, delete this one, this line is not required. Okay, then the product, the sum, change this by. Okay, let us terminate this program and run compile first. Indela is not needed here. Yeah, again compiling, no problem. Run here. Okay, good. First enter the first number, that 90. Please enter the second number, 5. Okay, the product is 450, the sum is 95, the difference is 85, the remainder is 80. The two numbers are equal. Process terminated execution. No, it is not work successfully because x and y comparison is the two numbers are equal is not work here. If x greater than y, cout the greater is x. Else if x greater than x less than y, the number is the greater is y. Else or default, there's a default keyword. This is called default. No, and like this. Okay, good. When run this one, okay, the first integer number 10, the second 4. The two numbers are equal, not equal. If x greater than or greater than y, cout x. If else if else, I think this one is the correct order. Right, this is the problem solution. I will show you again. Compile, run, enter the first number, let enter 10, and enter the second number, let 20. Okay, the product is 200, 10 times 20, the sum is 30, the difference is 10, negative 10, 10 minus 20, negative 10, the remainder is 0, and the greater number is 20. From 10 and 20, the greatest is 20, and the program is successfully terminated. Good. How the code works, it looks like this. First declare x and y, sum, difference, product, and remainder. Enter the first number, cnx, cout, press enter the second number, cny, product is equals x times y, sum equals x plus the difference, remainder x over y, and this syntax looks like. And if x greater than y, cout the greatest number is x. Else if x greater less than y, the greater is y. Unless else two numbers are equal. Just I show you when two numbers are equal. 10, enter the second number also 10. What's the output? Two numbers are equal, and the product, the sum, the difference, the remainder looks like this. Good. This is also the circumference of a circle is given, so you should declare pi const pi is equals to 3 0.1416 and r is equals to int, you can say int r is equals to some value, just 5 for example, and calculate cin r, because you already have pi value, cin r, then c is equals to 2 times pi, the value of pi is p times I times r, then cout c, then terminate. Please try this by yourself. Then the next one is another question before the next question. Please do this by yourself. For watching this video, I would like to say thanks for watching. ስለምትከታተሉኝ አመሰግናችሁ አለው። Please subscribe, like and comment, also share. Thank you.